The year is 1609, when the renowned Italian physicist and astronomer Galileo became the first person to point a telescope towards the skies and discover some pieces of evidence about some important questions that had puzzled humanity for centuries. But was Galileo the inventor of the telescope, or was he alone in the attempt? And who envisioned a telescope in space? Such questions have troubled many people, so stick with us as we go through the history of the telescope and unearth such questions and how all the events have led us to James Webb. Welcome to Technophilia, a show where we bring you the top stories from the world of science and technology. So let's discover what's concocting there. The origin of the telescope is closely tied to the field of optics, which can be traced back to ancient civilizations such as Mesopotamia, Egypt, etc., which utilized lenses that were made from polished crystals. Centuries later, the Romans introduced lenses made from glass spheres, which were filled with water. These two types of lenses remained predominant for over 1000 years. The two important ancient scientists in this regard are the Greek scientist Euclid, who postulated basic laws of geometrical optics, and Ptolemy, whose works provided a strong foundation for the later generations. One of his most important publications is the Planetary Hypothesis, in which he laid down the principles regarding the structure of the universe and the laws that govern celestial motion, and attempted to compute the dimensions of the universe. Later, during the 8th and 15th centuries, numerous Islamic astronomers identified weaknesses of the Ptolemaic system and refined and expanded on his work. In this regard, Al-Sufi combined Ptolemy's work of mapping constellations with the Arabic astronomical traditions and presented extensive illustrations of each constellation from both side perspectives. His work was so extensive that to this day his recorded names of many stars are still used, and it included the first recordings of what was later discovered to be another galaxy, the Andromeda Galaxy, one of the only two galaxies visible to the naked eye. Perhaps the most important contributor in the field of optics was Ibn al-Haytham, also known as Al-Hazen, who comprehensively reviewed all optic theories dating back to ancient Greek, which earned him the title of Father of Modern Optics, and his book became the principal source for expansion, specifically in Europe, which later led to the development of eyeglasses in the 13th century. However, the first recorded mention of the telescope would occur in 1608, when Dutch spectacle maker 𝙁𝙁𝙥𝙥𝙦 filed a patent for a device that consisted of a concave and convex lenses in a tube, and which could allow viewing far away things as though they were near. However, he was not the only person to do so, but two other spectacle makers also claimed the patent. The patent was not awarded to any, as the government found the device too easy to be copied, though Hans was contracted to make several binocular versions of it. Only after a year, Galileo had managed to construct his version of the telescope, aimed at studying the skies. The initial telescope is said to magnify 3 times, which he later refined to first 8 times and then to 30 times. However, according to the Library of Congress, Galileo was not alone in pointing the telescope skywards, but there were numerous other people such as English astronomer Thomas Harriot. However, Galileo became the first to publish and widespread his findings. In 1610, Galileo published his initial results in a short treatise named 𝙨𝙪𝙗 Messenger, which later proved critical towards refining the understanding of the universe. For example, Galileo's drawings of the moon presented a radically different perspective. His work showed that the moon had mountains and craters, of which he also computed estimates, and that it was not a perfect sphere. However, Galileo's telescope had a problem. It refracted or bent the light, using one concave and one convex lens, which limited the field of view. Later in 1611, Johannes Kepler, building on Galileo's work, presented the notion of a telescope made from 2 convex lenses, which would allow a larger field of view. But the problem was that it would produce the image inverted. Thus, his recommendations were not immediately taken up until 1630, when a German mathematician, Christoph Scheiner, reported his findings from such a telescope. But Kepler's version also had a problem. The sharpness of the image produced by it was limited by chromatic aberration and would require lenses of great focal length. Thus began the race for building large-sized telescopes. However, in 1668, Isaac Newton shifted the concept towards a reflecting telescope, which utilized a single curved main mirror made of tin and copper alloy, accompanied by a smaller flat one. Though Newton's telescope presented good results, to much dismay it also had some problems. Firstly, grinding mirrors of regular curvature was extremely difficult. Adding to the problem, the metal mirrors proposed by Newton also needed to be repolished after a few months, also affecting their curvature. Later, many different scientists made their versions, but no big advancement would occur until almost 50 years later, when an English scientist, John Hadley, came up with the invention of precision aspheric and parabolic speculum metal mirrors, which were made from a combination of bronze and silver, which showed promising results. Hadley also contributed to the mount of the telescope and developed an altitude azimuth mount, which could effectively track objects across the sky as the Earth turns. His designs were later tested by many scientists, who were able to observe Saturn, division in its rings and 4 of its moons. In the late 1770s, William Herschel jumped into the scene with the invention of several reflectors, and with one of these he ended up discovering Uranus and earning royal recognition. Herschel, motivated by his success, continued to advance his designs and developed a large telescope with 20 feet long tube and a mirror 19 inches in diameter. Later he extended this to 40 feet, and many others also built upon his designs. However, the biggest problem associated with such telescopes was poor reflectivity and quick tarnishing of the mirrors. Thus, with the advent of the 19th century, began the golden era of refracting telescopes due to a technological advancement that solved the issues with such telescopes. In 1805, pkgnaod made a breakthrough when he experimented with clay stirrers to mix the glass in a furnace. To his surprise, it produced a flawless material. Such telescopes flourished through the half of the 19th century, among which the great Dorpat refractor, invented by the Russian scientist Fraunhofer, became part of the standard of telescope design, as it not only offered unparalleled optic power and precision, but its mount also had a clock mechanism, which allowed it to be driven at precisely the rate that counteracted the apparent daily movements of the stars. In the mid-19th century, American scientists jumped into the scene due to the American government's funding to enhance observatories. Though the initial observatories were equipped with European telescopes, that changed when American firm Alvan Clark & Sons dedicated its resources towards this field and became one of the world's preeminent telescope makers. Due to their reputation, they were approached by an American businessman, James 𝙁𝙗, who had no heirs and wanted to dedicate his resources towards building the world's largest telescope. This 36-inch telescope was completed in 1887 on an excellent observation site, Mount Hamilton, and soon Lick Observatory became one of the world's premier astronomy institutions. Soon another American businessman, George Hale, dedicated himself towards this field and managed to sport 3 important observatories, out of which Yerkes Observatory proved to be a milestone with its 40-inch telescope and its unusual approach to the field through photography and spectroscopy. Through these approaches, for the first time, scientists were able to work out the composition of the universe, what its matter was. Thus, during the 19th century, these techniques flourished with the aid of numerous scientists, whom all contributed a lot to this field through the discoveries and improvements. However, in the 20th century, the focus once again shifted to large research reflectors, which were designed for precision photographic imaging and located at remote high-altitude clear sky locations, such as the 60-inch Hale telescope. This was since in the 1850s, Steinhale and Foucault had introduced a process of depositing a layer of silver on glass telescope mirrors, which minimalized much of the problems with such telescopes. But still, these mirrors needed to be redeposited with silver every few months. However, in 1932, John Strong became the first person to illuminize a mirror, which lasted much longer than silver, and soon such large reflectors began to be developed, out of which Hale's 200-inch telescope became an archetype for the modern research telescopes. The rush to develop radar tools for military purposes during World War II also had a significant impact on the field of astronomy, as scientists now had access to newer and better tools. Thus, in the 1970s and 80s, two new technologies were introduced: active optics and adaptive optics, which provided better image quality. Similarly, during that time, scientists also started exploring new wavelength regimes, such as the radio and infrared. Moreover, scientists soon began to realize the need for a telescope in space due to the distortive nature of the Earth's atmosphere, though the notion of a telescope in space is attributed to Lyman Spitzer, who wrote a secret report in 1946 called Preliminary Design of an Experimental World-Circling Spaceship. According to him, such a telescope would be truly able to see the images unaffected by the Earth's atmosphere. Thus, in the 1970s, NASA and European Space Agency began working on the Hubble telescope. After 2 decades of hard work and trials, scientists finally realized this long-held dream and launched the Hubble telescope in space. There is no doubt as to the wonders Hubble has achieved over the decades, with its plethora of new information and unprecedented images that have much advanced our understanding of the universe. And after another few decades, scientists have managed to build and deploy the most powerful space telescope ever built, James Webb, which is roughly the size of a tennis court. To understand how significant Webb is, it needs to be compared with Hubble. Firstly, its mirror is 7 times larger than that of Hubble, and where Hubble was merely 570 kilometers away from Earth, Webb is expected to reach 1.5 million kilometers away from Earth. In addition, Webb will go beyond Hubble in wavelength too, as it will utilize infrared cameras to see through the dust in our universe, where stars and planets form, and can catch even the faintest of signal. These are some of the advantages of Webb, as it's full of intricacies specifically designed by scientists to make it more powerful, such as its 5-layered sun shield. Up until the upload date of the video, Webb has already traversed the major part of its distance and has overcome the biggest challenges, such as unfolding of its mirrors. It is now a couple of days from its destination, and scientists are hopeful that it will open another world of mysteries regarding the Big Bang and baby galaxies, and will deepen our understanding of the universe. What exactly Webb uncovers, only time will tell. In the meanwhile, don't forget to tell us your expectations and theories about what it might actually discover.